thank you very much. That was a great talk that Kim, and you know, this is very exciting to talk to you about you know, what motivates us. And I didn't follow your presentation, but thank you anyway. So what light my fire? Well, actually, you know, I think that what light my fire is my inner control freak personality. But actually, it's perhaps you don't know, but you too have an inner control freak personality. And actually, the humankind has an inner control freak personality. Since when we were in, you know, thousands of years ago in a cave, and we learned as humankind how to control fire, we understood that controlling things was letting us survive. And now, what we discovered, you know, a few hundred years ago with science, is that actually there is the most sophisticated way of controlling. And the controlling is prediction, predicting what will happen in the external world. This is really saving lives. And we were so good at prediction that now at your fingertip, you find when it will be the next total eclipse of the moon, 1,000 years in advance with a precision of milliseconds. And then you can go, probably you do every morning, you go and you check for the weather forecast. And then we can go and do better weather forecasts like the one that we do for hurricanes, that every year saves thousands of lives. But then there was something that was puzzling me, you know, because we were so good on many things in natural sciences, but then, you know, many things that actually are around us and are the most dangerous, we are not so good at predicting them. We don't predict the emergence of a conflict. We don't know how to manage catastrophes. We don't know how to predict the next pandemic. But actually, we don't know how to predict the next traffic jam. And that's even more worrisome, you know. And why is that, you know? Especially if you consider that in a world that is more and more connected, more and more, you know, prone to failure that can ripple through the system. Well, the issue is that, you know, in all those systems, we are part of it. The social atom, you, is part of the system. And you know, the common wisdom in this case is that you cannot use the social atom as a physics atom. You know, we have too many infinite cognitive and psychological dimensions to make systems predictable. Well, you know, however, there is another vision that actually comes from social scientists, even 100 years ago and more, that we can actually build a physics of social systems. And well, you take yourself, the social atom, and then you build the social molecules, you know, the households, the workplace, and then you put a lot of social molecules all together, and then you build the social aggregate. You have a description of the social aggregate. Well, that's a very ambitious vision, and you say, well, can we really do that? Well, I was lucky. I was, you know, growing scientifically during two major scientific revolutions, in a sense. The first one is the one that is concerned the science of complex systems and networks. That tells us that actually, you know, the myth of the ant queen is not real. If we understand how we interact in systems with many components, if we can map the web and network of interaction, we can understand the emergent phenomena without the need of leaders' blueprint. Most of what you see around you is not because there is somebody that decides about it, but just because it's an emergent phenomena. And the second part is that, you know, we finally have data that even 10 years ago was not even thinkable. We live in an era in which every year we produce more socioeconomic data than in all the previous history of the humankind. What kind of data? Those data, for instance, you have pervasive technologies. You have little tag that you can stick on kids in a school and just measure their interaction, their face-to-face interaction where they are in the class, when they go to recess, and so on and so forth. And you can do that on the workplace, you can do that at conferences, you can do that, you know, in the society. Well, you can zoom out a little bit, and then you get to look at a city. And then you can map how people move, how people meet, just by looking at the digital crumbles that your mobile devices leave when you go around. These are mobile phone traces in the city of Paris. You know, and you can look at those data and basically have a tomography of a city. Well, you can zoom out even more, and you can look at how we go from one continent to another, how we jump on a plane and go to the United States, or, you know, every place in the world. Each of these little trajectories is a plane with their people, and we have a complete map of that. Can you imagine what you can do when you start to overlay all those data? Well, the point is that data alone are not giving you predictions. They are just a picture. What is our crystal ball is a model. What is a model? It's like when you have weather forecasts. You need a model of the atmosphere. You need a model of how, you know, it works. And this is what we need to do. We need to get models for those data that rationalize and give us an understanding of those data. And what is the model? Well, 10 years ago, we decided to try to build a model for epidemic forecast, to try to get, you know, to can we chart the next pandemic? And where do we start? We do start by mapping population. We look, you know, at very high detail population maps, 10 by 10 miles grid over the world. And then you look at how those people move from one place to another, you know, by plane, by commuting, by car. Well, then you have a synthetic world. And in this synthetic world, you can put a disease in it. Well, that means a few infected individuals, and there is no model that fits all disease. For each disease, you need a specific model, epidemiological data. But then, if you have those data, and you have the initial conditions, you can start to project what will be the evolution of the disease. When, how much, where it will hit and strike next. And what do? Well, you do those kind of things like, for instance, a scenarios analysis. You can say, well, let's create a model and let's do a kind of synthetic pandemic that starts from London here, and let's look at all the people, how they go from a single plane connection to other places in the world and see the infection all across the world. Well, that's obviously is just a scenario, but you can use those things in real time for real cases. And now probably most of you know that we are facing one of the probably biggest epidemiological threats since many, many, many years, is Ebola in West Africa. 5,000 deaths, 13,000 cases getting in the United States and other countries in Africa. So what we want to do is to understand how it will spread. And those techniques allows you to do that. You can look, you know, at what are the most countries at risk. You can look at how it spreads around the world. You can look at things like, well, can we say how many cases we will have in West Africa? And you will do as in weather forecast. There is a winter storm, and you will read that there will be between 6 and 10 inches of snow. Well, I can tell you with those methodologies that there will be between 6 and 10,000 cases at a certain date. Much more. You can even look at the how and when. You can look how many cases can we expect in the United States in the next month? 1, 2, 3. With which probability? Well, all that information is actionable information that you can use for policy making. How can we, you know, curtail the epidemic in West Africa? How can we make better policies in the US to protect us? You know, do we do travel bans, travel screening, and so on and so forth? Well, you know, this is epidemics, but there is still another problem that is really, you know, lighting my fire. Because if you think about epidemics, you think about contagion. But biological contagion is just one phase of contagion phenomena. There is a lot of social contagion. You know, there is knowledge. There is ideas that spread. There is political consensus, opinions. You know, all that are things that evolves like a disease. You talk to a person, that person get convinced or not, get infected or not by your vision, your idea. How can we do that? Well, you can use the same models. Obviously, it's a contagion phenomena, but you have to go from a geographic space to another space that is the social space, your friendship, how you communicate, how you interact with people. And do we have a map of that social space? Well, no, till 5 years ago. But now we get those kind of maps. This is, for instance, our Twitter exchanges, messages in Spain, you know, and how they infect different places to give rise to the protest of May the 15th. That was a major protest in the capital city. This is the building up, you know, of a social collective phenomena through a contagion phenomena that you can finally map, because you can start mapping the social space. And that's really, for me, the big problem. It's still open. Obviously, we are going toward achieving predictive power for social system, but that doesn't mean that we will know what will happen. We will have a geographical map, you know, a kind of chart of what could happen, but then obviously the decision at the end will be always yours, that will decide what to do. But we are opening, you know, Pandora box of problem, very interesting problem. And, you know, my suggestion is, you know, I have a big problem, find a big problem and let your fire burn it, okay, and solve it.
Thank you, Alex. That's great. Questions?
Thank you. Don't be scared. Come on.
Yeah. Infected, yes.
How many cases?
No, come on.
Go ahead.
How many cases in Boston?
How many cases in Boston?
Yes.
I think zero. Well, very few. Probably between now and November, no more than 1 or 2. Between now and December. But this is generally for United States is still a very small number. And actually we got very good news yesterday. So actually the epidemic is starts to have to slow down a bit in West Africa. So it's too early to say, you know, that is under control or anything like that. Actually this is the moment to be more aggressive, but finally there are good news after 2 very, how to say, bad months.
What do you think was the reason for the change?
Well, actually, you know, there have been a lot of effort, and I have to be honest, you know, United States are really leading the effort. I'm very proud of what United States have done. They have been sending a lot of people, mobilizing forces, coagulating the international effort. So, you know, and a lot has happened in the last month and a half. So now there is more teams, there are burial teams, there are more hospital beds, and things are hopefully getting under control. It's obviously a very homogeneous and moving situation, but we hope for the best.
Excellent. Any other questions quickly?
Where do you see this technology having the most impact? Like what field? Or what do you think it's going to be? Like where do you think it gets used first, and where do you think it has the biggest impact?
Well, you know, the question was what is the field where you see the largest impact for those technologies? I think all fields, you know, in a sense will be affected, because it's our, can you imagine what is the paradigm shift when you start predicting things where, you know, the human is in the loop, the social component is major. But you can start from viral marketing and how we can do things like that to can we predict the science of science that my colleague Laszlo Barabash is working now. So can we understand earlier what are the areas of science that we need to foster to spread better. Obviously all the medical applications, you don't have just, I always talk about infectious diseases, but you can think of also of other diseases, habits, you know, how obesity spreads, how other, you know, smoking habits is another social contagion phenomena. So these are all applications that you can imagine. And obviously there are other applications like more in the political domains, how you wanna, you know, favor certain ideas, give momentum to certain ideas or things like that.